Hello viewers, welcome to the video lecture series of the job role Soil and Water Testing Lab Assistant for Class 11th. Unit 1 Introduction to the Soil. Student, in today's session, that is in session 2, we will look into the soil and its physical properties. But before it, let us know about these important terms like soil is derived from the Latin word solum, which means floor. It is the outermost layer of the earth which is formed by the withering. Soil is a thin layer of the earth crust which serves as a natural medium for plant growth. Typically, all soils are differentiated into distinct horizon or layer, which are illustrated as follows. The topmost layer is the O horizon, consists of the humus substances. The second layer is known as the A horizon, known as surface. Likewise, the third layer as B horizon constitute the subsurface areas. The C horizon is well known as the substratum layer and the R horizon layer as the bedrock layer. Student, now let us look into the various components of the soil. Soil is not a homogeneous medium. It constitutes of air, water and minerals. For better insight, student, let's look this figure. Typically, the soil is divided into two parts. The solid portion of 50% and the 50% of the pore space. Out of this 50% of the solid parts, the 45% consists of the mineral matrix and 5% as organic matter. Similarly, under the 50% of the pore space, 20 to 30% of the space are constituted of air and 20 to 30% constitute of water. Student, let us now look into the various properties of the soil. First, the physical properties of the soil. Soil physical properties are essential for the movement of water, air, nutrient and also for the heat transmission. These properties are also responsible for providing better root anchorage to plants. Student, so let us look one by one these different physical properties. That is color, texture, structure, moisture content, pore space and bulk density. Student, you must have noticed that when you travel from one location to the another location, you came across differently colored soil, such as red soil, black soil and brown soil. Color is one of the easily observable features of the soil. Soil color gives an indication about a different constituent such as clay content, organic matter and the presence of iron and aluminum oxide. Student, soil can be better understood by its color. In the following figure, you can see the 8 different types of the soil profile which is based on color. Viewers, soil color is easily observable parameters which is determined by the Munsell color system. This color system is developed by the Professor Albert H. Munsell. The color system is based on 3 properties: hues, values and chroma. Whereas the hues is the wavelength of the color, value represent the tone and the chroma represent the color saturation. Student, soil color is one of the mostly easily identifiable characteristic of the soil. Just looking at the color of the soil, you can understand the importance of the soil. Overall, the soil color indicates its productivity, about the parent rock material, place, climatic condition, and how the soil formation took place. Students, the next physical properties is the soil texture, which can be easily understood by the following points. Texture is a physical parameter which indicates how the soil feels to touch. Technically, it indicates the relative content of the particle of various size, that is, sand, silt and clay in the soil. Therefore, the soil texture influences the amount and the movement of the water, nutrient and air in the soil system. Based on the size of the soil particle, soil are classified as follows. the sand with a size range from 2 to 0.02 millimeter, silt with a size of 0.02 to 0.002 millimeter, and the clay with a size range from less than 0.02 millimeter. With varying content of the soil particles or possible combinations, there are 12 different soil textural classes. These textural classes can be displayed inside a triangle, which is also known as the triangle method of the soil texture determination. Here, in this textural class triangle, each side represents the soil particle class like percentage of the silt, percentage of the sand, and percentage of the clay. The intersecting point of the silt, clay, and the sand determines the 12 different texture of the soil, which you can see in the textural triangles like sand, loamy sand, sandy loamy, sand clay loam, loam, clay loam, sandy clay, clay, silt clay, silty loamy clay, silt loam, and silt. Student, for determination of the soil texture, two different methods are used in laboratory. Both the methods are based on the principle of soil sedimentation. Student, let us first look into the international pipette method. In this method, a suspension of the soil in water is made, and the sample is pipetted out at different time intervals and at different depth from the suspension in a measuring cylinder. The pipetted suspension is dried, condensed, and the percentage of the soil particles settled is determined. The second method is Bjorka's hydrometer method. In this, soil solution is poured into a tall cylinder fitted with hydrometer. Once the hydrometer is settled down, its hydrometer top meniscus reading is noted at 40 seconds. Subsequently, reading for the silt is noted after 1 hour and for residing clay is noted for after 2 hours. So student, let us summarize what we have learned in this session. We have learned about different types of the soil horizon and its component. We have learned about soil color, which is based on chroma, hue, and values. We had seen about the soil texture, in which we had understood that it is based on soil particle size that can be classified as sand, silt, and clay. Student, we have also learned two methods for the determination of the soil texture class, that is pipette method and hydrometer method. So student, that's all for the today's session. Till then, keep watching and enjoy learning. Thank you.